All right, so what we are looking at is slope-intercept formula, which actually is one of the most handy formulas that you can use in algebra, also known as slope-intercept form. It is literally taking specific variables and using the substitution property of equality and replacing them with given sets of values. So it is in the format of y is equal to mx plus b, where in this instance, y and x are relating to a set of ordered pairs that's on the line on your graph. And for that line, you also would have a slope, and that is the m value. So for the task at hand, what you're doing is you are finding the b value. And the b value here is referring to where this set line, where it is going to cross the y-axis on the graph. So this fancy formula basically is saying, hey, you got a set of ordered pairs with the two variables, an x and a y. You got a slope, and you have a y-axis. Where is this line going to cross that y-axis? So that's what you're finding. For the purpose of the water part, the linear functions project, you are trying to find b. So in order to do that, you are going to use the values that are given from one of your lines, say an x and a y from one of your lines, and you're going to use the slope that you found for that line, and you're going to replace them using the substitution property of equality for the variables that exist in the equation. Now, a couple things to consider is that when you're looking at a graph, if you have something that is running parallel, remembering that this is your x-axis running left to right, and this is your y-axis running north and south, that if you have something that is running parallel to that y-axis, it will never cross the y-axis. So it's not possible for it to. So what we're doing, like I said, is finding b. However, anything else would clearly, even if it's at a very small angle, it may be a long time before it actually extends across the y, and that's what you need to do is visualize where it crosses it eventually. So let's say that we have an ordered pair of 3 and 7. And let's say that that line has, I'm going to just make up some values here, a slope of 7/3, which would have been found in previous tasks for the purpose of the linear functions project. What you're then going to do is you are going to use the substitution property of equality to replace these values into the slope-intercept formula. So we have an x and we have a y, and this is our m. So 7 is equal to 7/3, there's the slope, times x, which is the 3. I'm going to go ahead and put it as 3/1 because it's implied, plus b. So the only variable left is the b, which is why I'm solving for it. So now I go ahead and multiply this as 21/3, which simplifies to 7, plus b is equal to 7. I can subtract this, and that gives me, and I'm subtracting this because it is being added to the equation. It's a positive 7, and the opposite of positive 7 is negative 7, and we would like it to be gone from this side. And if I've done it to one side, I actually need to do it to both sides. So it gives me nothing here on this side, but the b still exists. So I'm going to go ahead and bring the b down, and now it actually says 0. So what that's saying is that if I have a line that has an ordered pair of 3 and 7 with a slope of 7/3, that it will cross the y-axis at 0. That is what that is saying. So this is the y-intercept of the line with those parameters. Now the only other thing is when you're looking at the task for the linear functions project, also known as the water part, that it has, like, it needs it in y equals something x plus, let me see, the x, yeah. So these are the values. They do not want you to put the ordered pairs in here. What you're going to go ahead and put in the final format is the slope and where it crosses the y-axis. Knowing that occasionally this may be a negative value, so that your equation would actually have maybe a negative value there. So if it was this line that I was referring to, the final typed product, and I would show and type all of these steps in my box as well as on my paper, the final product would then be that the slope was 7/3, and then I have an x, and then this was a crossing at the 0 on the y-axis, and that's what it's asking you to do.